Okay, short video of this first test. Hopefully I'll be able to edit all this into one video if I can keep it short. Okay, microphones are placed all clustered together, not exactly in the same kind of HD worlds or time and space 3 dimension, because they are in different actual dimension of 3D space. But since I did the frequency sweep, firstly I had to calibrate using a sine wave and get them adjusted, and then just make some small adjustments on the gain level or on the levels here, so that the tone was at the same level for each microphone. So I'll just go sit back here, and I'll just quickly zoom in, and this will be the first part of the so I'll just go to the overlay and zoom in. Now I did a slight offset on the by checking each one left to right, or rather each. So if I go down and I check one off and then put one back on, and I just adjusted the offset so it would overlay on the but I could see that once it got up to a certain frequency point, it started to deviate a little bit. It's not drastic. It's between I think between these points. If I zoom in a bit, I mean, looking at about a dB or so, which can be a little bit drastic in the differences of the each microphone. So it's like having this is, I think I'm using 3rd octave here, or is it no smoothing? No, it's no smoothing. Anyway, so that just tells me there. Okay, now we'll place the microphones back in their positions, like near the bass drivers, and then do the frequency sweep. And then once I've done that and done the checks and calibrated it, checked it, I'll have to check any phase differences to see if there's anything going on, check polarity, make sure anything, to check that nothing has got kind of mistakenly miswired, and polarity is going to be pushing the speaker driver in the opposite direction when it should be going forward. Simple ways to check those things are to check with a 1.5 volt battery to see if the cone has forward motion. So I know the cones are all going forward motion, so differences with the frequency. So okay, so that's expected, and I'll just triple check or quadruple check. So if I overlay again the green one, it's kind of falling on top. Green one. So the microphone here, that'll be from the left. The one right in the middle there is from my center channel, and the one on the right side will be from my right channel. So I'll just check again. It's roughly about a 0.2 dB offset there on that one. I'll check that one off and check this one on. And look at that. That's on number 3. Up, down a bit. Might be about 4. Up a bit. well, it might be about 0.4 there. Might be about 0.4, and add that one on, but still, you can see it kind of really starts, you know. So on the low lows, it's kind of, you know. But point here testing is to see that if there is any differences in the speaker bass driver, the JBL 2226, which is fitted into the JBL 4647 Cinema. There are Cinema speakers behind the screen. So, okay, second part of the video. If I can edit this into one video and keep this short, I'm just adjusting the gain levels on the DCX according to just adjusting the offsets here, and then done a check for an overlay. So if I turn that one off there, that's the left channel. That's originally the frequency sweep I did earlier, and I had to set the offset down a little bit by about 2 dB. That's pretty drastic. And then I did the sweep again, but I adjusted 2 dB minus 2 dB on the DCX to get it kind of, yeah. And so all I'm looking at here between the graph are just some differences that need to be adjusted, otherwise they may possibly register at the seating position. Of course, now if I bring the microphone back here, I've got to bring the microphone back, but that'll be much later if I, you know, may need to, may not need to. I'll just see how it goes here, because I know what to listen for with like half pan sounds in films and such. So if I get a half pan sound over to the left, or the person or the car, whatever, moves over to the left, and then I think, oh, I wonder if there's going to be a half pan sound here in this movie. Or is it going to be a hard pan? If it's a hard pan, it won't be in the center. If it's in the left and the center, it's a half. So if you have a suitable decoder, the sound would then come onto my left center, or over on the right center. So let me just have a look, and then I'll go into the do some adjustments on the PEQ. The right channel. Oh, that's the right channel there. Switching it on and off. There it is. This I adjusted with a little bit of offset. Gosh, that's number 6. So I looked at maybe a little bit more dB cut. So if I bring it down a little bit more, to kind of level the low end sort of thing, more or less, with the, not that it's going to be entirely, but it'd be, you know, then I would have to use then minimum PEQ filters to adjust for the compensate for the frequency differences with the room's the interaction with the speaker interacting with the room and its boundaries. So yeah, 3.8 dB there. Okay, and take it back up to 1.6 dB, and then think, yeah, okay, hang on, I need to, there we go. So I might post this on the audio science later. It's my screen's going a bit dim here. There we go. To brighten it up. So I might, yeah. So I'm just going over this, just checking just to see where I need to validate and see where I need to place the PEQ filters. I mean, it most likely I may run out of PEQ filters. Once I've slightly adjusted this up here and all that, I'm then going to set the crossover slope down to probably about 400, 500, 400 hertz. Links Riley. I might set it a little bit lower. Just depends on how I feel, which is what an auto EQ can't feel. Auto EQs, they don't have feelings, they don't have a emotion, they don't have well, they're just programmed. So I go on what I have to listen to, because I doubt an Odyssey or all these day racks or whatever they are, I doubt they'll be able to say, well, I don't think this is going to work very well with a half dialogue pan or half dialogue or half pan sound effect or whatever. You got to get a nice consistency, you know, and I got to do other checks with checking the phase and to see if everything, you know. So I run the pink noise and then play the other channel and then bring it up gradually, and if I start seeing it going out of place a little bit, kind of, then I'll adjust the phase, which is in in five decimal steps on the DCX, and adjust that until it kind of levels, and everything should multiply or sum up rather than subtract. Okay, checking the phase, the frequency of the speaker. Typically LCR at present, before I move over to doing the left center, right center again. Occasionally I use two RTAs up on the screen, depending on what sort of frequency testing I'm doing. You can use a dual trace oscilloscope on the true RTA, but if I wanted to use the RTA, I'll have to use two true RTAs up on the screen side by side, kind of like so, and then have one channel selected for left, one channel selected for right, and using the audio mixer with the pan pots set for left and one for right. I could do analyzing of the direct frequency response coming from the amplifier, whether it's got any PEQ filters added or not added, and I can evaluate looking at the frequency response. Obviously the frequency response is going to be like wow on the amplifier end, but when it comes to the speaker end, it's different depending on the characteristic frequency response of the speaker's capability, or what maybe you could tune the speaker just a little bit more, but you get a trade-off with, you know, the maximum sound pressure level, blah blah. But within a small room, it probably wouldn't be much of a big deal. In a big room, large, probably you need multitude of drivers and very careful adjusting, tuning, or better speaker drivers. So I'm just got two up on the oscilloscope at the moment. If I adjust the phase, polarity. So see a waveform there, that's up to the top there, and that one there down at the bottom's gone the opposite direction. So it's out That's not in polarity correct. That's polarity correct. That's the right channel over there. Put the center channel on. I've got a set cam for that one there. And there goes. It's checked okay there. Put the left on, put the center on. And there should be an increase. So the waveform kind of goes up a little bit more higher because adding on more tone gives some signal, so it increases by several dB more.